My name is Cristina Jimenez and the topic I am going to discuss is how to improve the extraction of drug interactions with Gaussian noise. The therapeutic benefit of a drug depends mainly on its ability to produce desired effects as well as undesirable effects tolerated by the patient. But when the patient consumes more than 2 or more drugs, one of the prescribed drugs may deprive the patient of the therapeutic benefits. That is, an interaction occurs between these medications where the risk of adverse actions is increased. Especially in this time of pandemic where vaccines, medicines, treatments are needed. Therapeutics are made in the shortest possible time. The reasons presented above make it necessary to deepen efforts to improve pharmacovigilance systems with more robust models for extracting drug interactions. Due to the complexity of the biomedical literature, high levels of performance have not been achieved in these models. To give robustness to these models, this research project proposes to use data augmentation techniques, for which we characterize 2 models that report good performance in the state-of-the-art. The strategy to be used consists of injecting disturbances through noise. The architecture of Model 1 presented on the screen is based on 2 previous models, a piecewise convolution model and a multi-channel model. The part-by-part convolution model manages to characterize the process of extracting and capturing structural information between drug entities. Besides, successfully extracts the relationships between these entities. The multi-channel model makes use of 5 versions of word embeddings such as input channels for the model, convolution by parts, and enriches the unknown terminology. The Model 2 architecture is a domain-specific language representation model pre-trained on large-scale biomedical corpora. It is a transformer multi-layer bidirectional encoder. The approach of the VIR model is to render a couple of sentences or just one in a sequence of tokens. The input of each token is generated by adding the token, segment, and position embedding. These 2 models are added a layer of Gaussian noise prior to the activation of the Shock Max feature in the 2013 mining challenge. The first models were the statistical models that reached an effect maximum of 0.6 then with the appearance of deep learning. These models achieved a score of 0.7072. Then came the pre-trained languages that gave robustness to the models and with which they reached EF scores from 0.80 to 0.82 with. In our project, adding Gaussian noise, our models achieved better metrics in that score. Especially the Violet model. On the screen we observe the evaluation of the model according to the number of examples. As we can see, learning is proportional in the 2 models. On the screen we see the confusion matrix in which it allows us to see the misclassifications when adding noise to Ocean. We see that in the first model the misclassifications are almost nil. In the confusion matrix of the BioBear model, we observe that as Gaussian noise increases, misclassifications decrease in many cases to 0. In this study we have tested how to increase the robustness of the models by increasing Gaussian noise. We found that when a Gaussian noise layer is added to these models, the performance of the learning techniques improves on the relationship extraction task, particularly in situations with a limited number of examples. In this study we tested how to reduce the number of misclassifications of 2 robust models using the use of data augmentation approach. Clarified details of misclassification as unbalanced data. they can affect the performance of the model. These results show that adding a Gaussian noise layer is possible. More accurately predict the relationship of type int. That it is the most complex class and that it easily confuses the negative, effect, mechanism and advice type relationships. Our study provides the perfect framework for future studies evaluating data augmentation techniques and the improvement of natural language processing models. Future job. The next stage is to replicate the gas model for the model via BioAlbert. This model is generating very good results in the biomedical task of natural language processing. Apply other data augmentation approaches used in the field of computer vision that are successful in visual tasks.